Ever wonder how magnets pull objects, or how your phone's wireless charger works? The answer lies in electromagnetic forces and magnetic fields. Welcome to Science Bites. Today we'll uncover the relationship between electricity and magnetism, two forces that are deeply connected and drive much of our modern technology. So, what is electromagnetic force? Simply put, it's the interaction between electric currents and magnetic fields. When electric charges move, they create a magnetic field around them. This means that whenever electricity flows through a wire, a magnetic field forms around that wire. The strength of the magnetic field depends on the amount of current flowing through. Magnetic fields are invisible, but we can see their effects. The direction of the magnetic field is given by the right-hand rule. If you point your thumb in the direction of the current, your fingers will curl in the direction of the magnetic field. The formula for the magnetic force on a current-carrying wire is F = ILB sin, thul, where F is the force, I is the current, L is the length of the wire, B is the magnetic field strength, and theta is the angle between the current and the magnetic field. In everyday life, electromagnetic forces are all around us. Your phone's wireless charger uses electromagnetic induction to transfer energy from the charging pad to your phone. Similarly, motors in electric cars use electromagnetic forces to convert electrical energy into mechanical movement. The technology behind electromagnets powers everything from speakers to MRI machines. Magnetic fields aren't just man-made, they exist in nature too. Earth itself has a magnetic field, which is why compasses work. The molten iron in Earth's core generates this magnetic field, protecting us from harmful solar radiation. Electromagnetic forces and magnetic fields are fundamental to the way the world works. From the smallest gadgets to the largest machines, they play a key role in powering our lives. Understanding these forces helps us unlock even more innovations in the future. Next time on, we'll explore how induced currents can create motion in generators and transformers. Stay tuned for more bite-sized science. Like and subscribe to for more bite-sized science that makes the universe easier to understand, one concept at a time.